Yeah, good afternoon. Okay, in the morning lecture, we have uh, covered two examples based on the plastic analysis for the beams. And third example we have started, and some of the part of the that particular example we have covered. So we will continue with this example, that is example number 3, which is based on the plastic analysis of portal frame. So this was the figure I think everyone has drawn. So I will draw once again this figure and we will continue. So the 15 kilonewton per meter is the intensity of this particular UDL. Then 5 meter span was we have drawn. Then this is the 1 meter span. Here 3 meter span is there. So then again here this load is a 120 kilonewton, and this is a 80 kilonewton load. Okay, so 1.5 meter span is there. Here again 1.5 meter span is there. So A, B, C, D. Okay, so this is the beam. So I think we have covered these two span. So for span CD, now we will calculate the collapse moment, or that is MP. We will calculate for this. So for the span CD, so last span, we will draw the mechanism first. So this is the actually beam having 15 kilonewton per meter intensity. Okay, am I audible properly?
Yes, sir.
Yes, sir.
Okay, so for AB and BC span we have seen in the morning lecture. So we will analyze plastic analysis of CD span, and that span carries a 15 kilonewton per meter UDL. Okay, so now we will draw the mechanism for this. So how looks this particular how we can draw the mechanism for this UDL? So if you see, this is the basic mechanism for the beam. Then the UDL is there. So what we are generally doing when UDL is there, we are converting into point. Are you getting?
Yes, sir.
We are converting into point load. So now, while we are converting into point load, this point load is acting. This point load is acting at a distance from continuous support. From the continuous supports, this point load will be 0.5 just point at a distance of 0.586 L. This point load is acting from the internal support or continuous support. So C is the continuous supports and D is the end supports. So from end support 0.414 L. So 0.586 and 0.414, addition of these two is 1 L, correct? 586 आणि 414. So addition of these two, it will be 1. Okay, so this 586 plus 0.414, it will 1. So from the center or from the continuous supports, it will act a 0.586 L, and from end support it will act a 414 L. म्हणजे हे exactly central act होत नाही. So during if you solve many examples of the intensity like this 15 kilonewton, so the load act at a center always, correct? 15 into 5, The 75 load act where? At center, correct?
Yes, sir.
But here, this load will act from a continuous support. So C is the continuous supports. Continuous support kasun 0.586 L वरती, and from end support it will act from 0.414 L. So L is here 5. Okay, so this is the mechanism here. So then this is the displacement. Then now at C moment, tell me at C point, the moment will be present or not? C support.
Yes, sir.
Whether C is the which type of support is there?
Continuous.
Good. This is the continuous support. So here hinge will be there, that MP will be there, and rotation will be theta here. Now here rotation,
No.
here rotation is theta. So here what is the value of rotation?
Theta.
Is the theta or it will be different?
Different.
Why? Because this is 0.86 L and this is 0.4 L. म्हणजे दोन्ही distance same आहेत का? नाही. If these two distance are separate, then this value will be theta 1. So again, this is theta 1, this is theta. So here MP will be there. Here again MP will be there. So now this end at point D, what will be the moment?
0.
Why at D moment will be 0?
Because it is simply supported.
Simply support. Good. At fixed support, movement will be present. At continuous supports, movement will be present. So D is the simple support and end supports. If D is the continuous supports, then here movement will be present. But
generate.
yes, but here D is the end support and simple support. So here movement will not be there. So at D, movement will not be there. Only 3 movements will be there. Are you getting, everyone? So now we have, this is the our what mechanism. This is the our beam mechanism for beam carries a UTL. Beam mechanism. Okay. So again, by using virtual work method, principle. Sorry. By using virtual work method principle, just need it. So what says the virtual work method principle? What is saying virtual work method principle? External work done is equal to internal work. It means whatever external forces acting on a body, and due to this force, whatever displacement will occur, it will be the same due to this external force, whatever internal forces are generating. Are you getting? And due to that displacement occur. म्हणजे जेवढा एक्सटर्नल फोर्स मुळे जी काय डिस्प्लेसमेंट होते आणि त्याच एक्सटर्नल फोर्स मुळे जे काही इंटरनल फोर्सेस जनरेट होतात आणि त्याच्यामुळे जी डिस्प्लेसमेंट होते, that will be the equal. That says the virtual work method principle. So now we will calculate the external work. So external force. So calculate the external force. What is the external force? So force into displacement. It is our basic principle. Force into displacement is our basic principle. Now 15 kilonewton is the intensity of your load into, we have to convert it. So how much span is there? How much span is there? 5, no?
Yes, sir.
So 5, and it will act at 2.5. So force into actual force we are taking that 15 into 5. Actual conversion of your force is 15 into 5, but that force will be act at a center. So we have to take it is 5/2. Then displacement for this. How much displacement will be there?
0.414 theta 1.
0.414 theta 1 or 0.586 L
Theta.
here. L is pending here. This is 0.414 L theta 1. Now we have to put the value of L. So 15 into this 5/2 is 2.5 into 0.414. How much L? L is 5 meter theta 1. So now calculate this. This is the our equation number 1 in terms of theta 1. How much external work done? 15 into 2.5 into 0.414 into 5.
77.625.
77.625. It will be the external work done. Got it? It will be the external work done. So now we have to calculate internal work. Now we have to calculate internal work done. So internal work done is equal to again force into displacement. So here force is a movement and displacement is a rotation. Okay. So how many movements are there here?
3.
3 movements are there. 2 movements with rotation theta and one moment with rotation theta 1. Okay. So here MP theta plus MP theta plus MP theta 1. Correct? So 2 into MP theta plus MP theta 1. So now again, so here this value is theta 1. So now, but here, but 0.586 L theta is equal to 0.414 L theta 1. So now calculate the value of theta and it will put into the equation of this second equation we will put. So calculate the value of theta. So theta will, this here L get cancelled, correct? So 0.414 divided by 0.586. So how much theta?
0.706 theta 1.
0.706 theta 1. So theta value is, it will be 0.6 0.706 theta 1. Okay. Now we have to put the value of theta in the equation 2. So before that we will equate and directly we will put the value of theta in the equation 2. So have you written this all?
Yes, sir.
Okay. So now, so we will go next. So now, so external work done is equal to internal work done. So external work done is 77.625 625 theta 1 is equal to internal work done is 2 mp theta plus mp theta 1. Okay, so now 2 mp theta plus 2 mp theta. So instead of theta we have to put the value, so that is the 0.706 theta 1 plus mp theta 1. So now calculate the value of mp. Before that solve it. This, how much this 2 into 0.706, how much this value? 2 into
4129. 4129.
1.4129 mp theta 1 plus mp theta 1. It means this will be the 2.412 mp theta 1, and this is 77.625 theta 1. And now calculate mp. So this theta get cancelled. So how much value of mp?
32.16.
32.16. 32.16 kilonewton meter. It will be the value of mp for the span CD. Okay, so in this way we have analyzed this beam for the plastic movement. It means at the collapse, at the time of collapse, how much plastic movement or how much movements will be developed in the particular span or that particular beam for AB, BC and CD. But these are the plastic movements. So what are the general movements, general bending moments for the span? We can calculate. So these are the plastic movements. So we can calculate the general bending moment also. So now we have to draw the BMD for this particular section. So draw the BMD, or we can write BMD. So for the calculation of BMD, we have to calculate first bending moment for span AB, BC and CD. So BM for AB is equal to, so AB span carries, we have to consider simply supported beam. General bending moment we have to calculate. It means this is simply supported beam, this is 80 kilonewton load, 1.5 meter is the span. So like this we have to consider all the supports are simple and we have to calculate. Sorry, and we have to calculate the general bending moment. So and we will draw the BMD. So for we will calculate in next page, because here so bending moment for span AB, BC and CD. We have calculated plastic moment. We will calculate the general bending moment. So span AB, if we consider span AB, the span AB is this is 80 kilonewton, this is 1.5 meter, this is 1.5 meter. So now tell me what is BM? If simply supported beam is there, central point load is there, how much bending moment for simply supported beam? What is the standard formula? You don't know. Simply supported beam is there.
WL square upon 4.
WL square upon 4 or WL by 4. It will be the WL by 4. So W is a 80 into L is a 1.5 plus 1.5, 3 divided by 4. Sonali, don't write on screen.
By mistake, sorry, sir.
Yeah, calculate bending moment. So how much bending moment for simply supported beam? WL by 4. So you have already calculated this. So how much it will be?
60.
60 kilonewton meter. Got it? So similarly, second span. This is span AB. We are calculating regular bending moment. So again, we consider BC span. Then 120 kilonewton load is there. 1 meter length from the B support and 3 meter length of the load from C supports. So calculate the bending moment. So bending moment for this. So this is the A and this is the B distance. So what is the formula?
WAB upon
WAB upon L. So W is a 120, A is 1 meter, B is 3 meter divided by total L. A plus B, how much? 4.
4.
So how much this? So how much? 90. Correct?
Yes, sir.
90 kilonewton per meter. So
Sir,
yeah.
करेक्शन आहे सर सिम्पली सपोर्टेड बीमच्या फॉर्म्युला मध्ये तिथे
हा
डब्ल्यू
कोणता? हा
डब्ल्यू एट आहे तिथं
इथे WL by 8 आहे का? W simply supported beam carrying central point load.
येस सर तिथे WL बाय 8 आहे
8 आहे आणि WL by WL ह्याचा काय आहे मग? For the span 3, third span, UDL is carrying. This UDL intensity is 15 kilonewton per meter. This span is 5 meter. Now here, how much bending moment here? Huh. How much here? For simply supported beam carries a UDL. Please do the calculation fast. Or tell me. So here WL square by 8. Who discuss, who talk? This is the for simply supported beams and carries a central load. So WL by 8. Who told me? Is this WL by 4 or WL by 8? Here WL square by 8 is there for UDL. I think this is correct. First AB span. So put the values WL square by 8. 15 into L is 5 square by 8. So how much?
46.875.
46.875 kilonewton meter. So these are the regular bending moments or general bending moments for this span if we consider the simply supported. So now we have to draw the BMD. So BMD. So we will draw the BMD here. So actually this is our span. This is our beam. So this is 5 meter. This is 1 meter. This is 3 meter. Again, this is 1.5 meter. This is 1.5 meter. So we will draw the BMD for this. Okay. So now AB for span AB. So regular bending moment BM, how much? 60 kilonewton meter. So central point load is there. So how the variation of this? कसं असेल? सगळं पुढे पाठ पाठीमागे सपाट आहे तुमचं.
Straight.
Straight line variation in inclined straight line variation. So 60 kilonewton meter A to B. So at A and at B, this is 0. Why? Simple supports are there. So at A and B, it will be 0. Now BC, span BC. For span BC.
Straight line.
Again straight line. How much? 90 it will be there. So it means, so this is 90. This will be 90 kilonewton meter. Then third, UDL is there. 46
Parabolic.
point. So parabolic is there. So 46. So here 46.875 kilonewton meter. So this is the general bending moment. Now we have to overlap the plastic movement on this particular beam. So plastic movement for span AB, how much MP? MP for span AB, we have calculated. Speak loudly. How much MP we have calculated for span AB? I'm waiting for your answer. This problem we have started in the morning. We have calculated the MP for span AB, span BC, and span CD. So you This is in your notebook. Why you are not telling?
30 kilonewton.
So when you will tell 30 kilonewton, I am expecting from you. Others, please. Is this for me only? If you not interested, please tell you our HOD. I am not interested to in this teaching. Others, please. I'm not telling now. I have given whoever given answer me, but all other. If you are not um, contributing, then how you will understood these things? You have to speak. If you don't understand, then tell me. I will tell many times. But don't sit idle. So 30 kilonewton. So actually for span AB, this is A, B, C, and D. So for AB, so support is this is this simple fixed supports. So here this act will be at fixed support 30 kilonewton. Then for span BC, this is 30 kilonewton per meter. 30 kilonewton meter. For span BC, how much? It will be 45. Exact 45. So this will be act at here 45. So this is 45. Then for span CD,
32.18.
32.18. So here 32.18 here. So for CD 30 and they add D and they add D, it will be 0 because D is the simple support and their bending MP was 0. Got it? So this is the your bending moment, regular bending moment and your plastic moment. So this overlap. So whatever part is this remaining, it will be the additional bending. So this is the overlap. So here we will highlight this part. So this part will be the combined part of your bending moment and plastic moment. So in this way, so here 45 kilonewton meter and here 32.19 something kilonewton meter. Okay. So in this way, we can draw the BMD for this particular beam by using the plastic method or plastic analysis of design method. So are you getting? In this way we can draw the BMD. Okay, so I will give one more example to you for the homework on this basis of this beam. Have you drawn this?
Yes, sir.
Okay.
Yes, sir.
So please your homework example. Homework example. So these are the 3 span again beam and on the all the span, on all the span, the UDL is there. On the all the span, UDL is there. So this span is a 3.5 meter. This span will be 5 meter. This span will be 4 meter. So intensity here 35 kilonewton per meter, 45 kilonewton per meter, and 55 kilonewton per meter. So this will be the homework. But I have to ask few questions to you. So this is span A, B, C, BC, and CD. So I have to ask one question to you. So this AB span is there. If we consider AB span first, then we will consider BC span first and then CD. And for each span, what we will do? We will calculate the plastic moment. Are you getting this? In this way, we will solve this example. But the span AB we will consider. So at that time, where point load will act? As I told you in the last example.
At the center.
And the center.
No. What I have told for CD span in the last example.
From the distance of 0.86 L from point A.
From simple support and from continuous support. So B is the continuous supports.
Yes, sir.
So from B, what distance, and from A, what distance? Please see the example, last example.
From A, 0.414 L.
It means for end support. See, from end supports, it will be 0.414 L, and from continuous supports, it will be 0.586 L. So this is for AB. Again, now this is CD. For CD, from end support, D is the end support.
0.414 L.
414 L, and here 0.856 L. Okay, now remaining span is BC. So it is at center. So now what?
0.586 L.
No. If the end span is there, AB is the end span, CD is the end span. बरोबर, end span आहेत ना, तीन मधला end आहेत दोन्ही, end चे span आहेत. So end supports पासून 0.414 L. Here from D, end supports पासून 0.414 L. But BC are these in continuous supports. So here, is this case is applicable because this is the middle span. The UDL lies on middle span. So here in this span, if span is middle, at that time it is exactly at 0.5 L, 0.5 L. So this keep into mind. If UDL lies on center span of the continuous beam, कंटिन्युअस बीमच्या सेंटरच्या स्पॅनवर जर ऍक्ट होत असेल तर लोड कुठे ऍक्ट होतो? एक्झॅक्टली ऍट
0.5 L.
0.5 L. It means exactly at center. Are you getting?
Yes, sir.
जर एंडच्या बीम असतील, दोन्ही एंडच्या बीम असतील तर तिथं हा रूल ऍप्लिकेबल आहे. 0.414 आणि 0.586 चा रूल कुठे ऍप्लिकेबल आहे? एंड सपोर्टला. युडीएल असताना एंड सपोर्टला. जर मध्ये कितीही स्पॅन असू द्या तुमचे, त्याच्यावरती युडीएल असेल तर कोणता रूल ऍप्लिकेबल आहे? This load will act at a center. It means 0.5 L, 0.5 L. Are you getting, everyone?
Yes, sir.
So
Yes, sir.
you can solve now this example. So we will stop here for today, and we will continue from tomorrow. I think tomorrow we have lecture, so we will solve the example based on portal frame. This is now we have seen some examples covered on the beam. So tomorrow we will cover the examples on the portal frame, and tomorrow we will end this chapter. Okay. So don't miss tomorrow's lecture also. So today solve this and draw the BMT. Got it?
Yes, sir.
So wait, I will take attendance and we will close. Just a minute.